Hello everyone. Today we're going to be talking about the derivative and how to interpret that derivative. So if we have a look at this graph here, so this is a graph of y equals x squared. It's a quadratic. Now the quadratic we have here has different points along this curve, and each one of those points will have a different gradient. So we can find what the gradient is at a specific point if we graph the derivative. So f dashed x over here, this blue line represents the graph of the derivative. So this red line here, if we look at the point, if we look at this point here, so we've got x is equal to negative 2.2 and y is about 5. And then we go down to the same x value here. So we've got negative 2.2 here. We can see that the y value there is negative 4.4. And that y value represents the gradient of the original curve at that point. So on the original curve, it has a downward slope. You can see that it's decreasing, and the y value is negative 4.5. So that negative value indicates that we have a downward slope or a negative gradient, which means that at this point here, negative 2.2, the graph is decreasing, or the instantaneous rate of change is negative. And if we look over here at this point, this is a point 2.4, and this blue line has a gradient of 4 at the same x point of 2. Now, coincidentally, that's the point where these two lines intersect, but it just indicates that at the point 2.4 on the original x squared function, the gradient is positive because we have 4 as our y value for the derivative. And that tells us that we have a increasing slope or a positive instantaneous rate of change. Now we can have a look at the turning point for this quadratic, which is 0, 0. If we have a look at the gradient graph, this blue line, that 0, 0 is exactly the same point. So at 0, 0, it has a 0 gradient as well. So that means that the graph is not increasing, it is not decreasing at that point, and that is because it represents the turning point. So it's the point where this original function goes from a negative gradient to a positive gradient. Okay, so that's a quick summary on derivatives and how we can graph the derivative functions.